Greetings, everyone. My name is Elizabeth Hutchens, and my final project idea is to create a watershed analysis model to identify potential flooding locations in the Hickory Landing training area in Sumter, South Carolina. LiDAR digital elevation model will be used to evaluate these potential flooding areas. The final product will be identifying the potential flooding areas using a set of hydrology toolsets located within ArcGIS Pro. In this video, I will discuss the purpose and objective of why this topic was chosen, an overview of the training area, the potential workflow for producing a digital elevation model using LiDAR datasets, and the potential workflow for the watershed analysis, and the data that will be used. The reason I chose this topic was because a request for information was submitted to my unit. However, no one, not even myself, knew how to properly perform a watershed analysis. So the purpose for this final idea is to create a how-to guide to creating a proper watershed analysis model for my soldiers for future requests. Because the original request for information was for a classified area, I chose to replicate the request in a local training area within Sumter. The objective is to use the tools learned in this course to identify potential flooding locations at the Hickory Landing training area. Objective Hickory Landing is a training area located approximately 36 kilometers from Shaw Air Force Base, Sumter, South Carolina. This training area expands by approximately 1.72 square kilometers, and the goal of this project idea is to identify the potential flooding areas within that training area. The workflow identified here is using ArcGIS Pro's spatial analysis extensions, hydrological tools, and the data management tools. The main step is to convert the LAS files to a DEM, including the LAS dataset and converting the LAS dataset into a raster. When doing this portion, it is important to be mindful of the coordinate system. If you forget this step, your LAS dataset will not cover your study area. In this case, we'll be using the NAD 83 UTM zone 17 north in meters. Moving into the hydraulic tool set, we will begin by using the full tool. This function fills sinks in a grid. If the cells with higher elevation surrounded a cell, the water is trapped in that cell and cannot flow. The fill function modifies the elevation value to eliminate these problems. We will then use the workflow direction for the given grid. The values in the cell of the flow direction grid indicate the direction of the steepest descent from the cell. Flow accumulation tool is then ran. This function computes the flow accumulation grid that contains the accumulated number of cells upstream of the cells in the area. We will then create a pour point. With this method I am using is the zoom tool into the area and copying the coordinate system of the stream of concern in order to create a pour point location, which I can then run the watershed analysis tool, which I can create a raster polygon of it. The data to be used will be LiDAR datasets that was downloaded from Open Topology. The LiDAR dataset downloaded was the USGS LPC South Carolina East Central 2017 LAS 2019. Before beginning to create a raster from LiDAR, some basic factors need to be evaluated. The extent of the LiDAR coverage, the number of LiDAR points and point density, the desired output raster resolution, the extent of the output raster, the format of the output raster. Using high spatial resolutions provided by the LiDAR digital elevation model allows for better predictions of smaller stream segments and improves definitions of watersheds extents, and can also provide details on areas of soil saturation. This final project will identify potential flood areas at the Hickory Landing training area and provide the framework of creating a proper watershed analysis. There is still some needed work to be done before the analysis can be complete, as in converting the LiDAR point datasets to a digital elevation model to extract hydraulic information, investigate the proper workflow to create a watershed model using hydrology toolsets, and convert the model to a watershed boundary polygon using raster to polygon tool. Considering this will be my first time conducting this analysis and workflow, any feedback or consideration is welcome. This concludes my final project idea. Thank you for tuning in and have a great day.